Hello everybody, this is Engineer Cindervis Bias, and in this video we are going to look at electric circuits and networks. As per some of the mails, the requests in some of the mails would just be looking at a few things which have been asked. So what we're going to be looking at now is how to tell whether a circuit element is in series or in parallel. Okay, say we have two resistors here, A and resistor B. Way to tell if these two are in series or in parallel. Let me connect them. Look at the ends of the resistors. These are the ends of resistor A. These are the end points of resistor B. Now these two ends are connected with each other, as you can see here. These two ends are connected. Now when one of the two ends are connected, go over to the other side. This end and this end. These ends are connected as well. So you have these two ends connected to each other and these two ends connected to each other, which means this is a parallel connection. And you say you have resistor C here and resistor D, okay, and you have, look at the ends, these are the end points, and these, only one pair of the endpoints are connected to each other and the other pair are connected to a battery or something else. So you have only one pair of the endpoints connected to each other. So this is in series. It does not matter what shape it is in. I can have a parallel circuit like this. Okay, this, if you ask me to find the potential difference or the equivalent resistance between X and Y, these two appear to be in series, but no, they are in parallel. Look at the ends, the end points of these resistors. Look, these two ends are connected to each other and then these two ends are connected to each other. So this is a parallel. This is a parallel connection. Whereas, don't go by the shape of this connection, just look at the ends. If both the pairs of ends are connected to each other, this is a parallel connection. And if only one pair of the ends are connected to each other, it is a series connection. Next up, we'll be looking at current sources and voltage sources. This is a current source. You have a current source of 5 amperes here. Current source of 5 amperes. And in current sources, always remember, in current sources, the resistor is in parallel with this current source. Look at the ends. The ends of the current source are connected to the ends of the resistor. Both ends of the current source are connected to both ends of the resistor, so they are always in parallel. Okay, these are the endpoints. Okay, the endpoints are all connected to each other, so they are in parallel. And now we have to convert this circuit, this current source, into a voltage source. So it's very simple. All you need to do is use Ohm's law. V is equal to IR. All of us know this. And now just remember, in a current source, they are in parallel. In a voltage source, just draw this, they are in series. This is the voltage source. This resistance and this resistance are the same. They do not change. The resistance remains the same for a single voltage source. And now we have to find out this voltage. We know the current here. We know the resistance here. So V is equal to IR. So we don't know V here. So V is equal to I. That is 5 amperes. 5 into R. R is 3 ohms. 5 into 3. that is 15 volts. So this is a voltage source of 15 volts here. So we can write 15 volts, and the voltage source, the ends of the voltage source, only one end is connected to one end of the resistor, so it is in series here. So here we have the conversion. The resistor remains the same resistor is used here, only this current source changes into a voltage source. And to find out the voltage, the V, we use the formula V is equal to IR, and we get 5 into 3 is equal to 15. So now here we have a voltage source here. We have a voltage source of 90 volts, and we have a resistor of 3 ohms. As I told you, in a voltage source, the resistor and the voltage source are in parallel. Okay, this only one end of the voltage source connected to one end of the resistor, the other two ends are free. Okay, so this is a voltage source. You need to convert this into a current source. Just draw it. Okay, just draw it in a current source. Remember, in a current source, the current source is always parallel to the resistance, always parallel to the resistance. Just draw it here. The resistance, as I told you, will remain the same. It's 3 ohms here, it is 3 ohms here. Just write 3 ohms here. It's the same resistance. And then now again, according to Ohm's law, I is equal to V by R. I is equal to V by R. You need to find I here for the current source. You know V, you know R. So V by R is 19 by 30. That is equal to 3 by 1. That is equal to 3. So 3 amperes. Next, we'll be looking at star delta transformations and delta to star transformations. This is a star network. Okay, this is a star, and you have to convert this into delta, meaning you have to convert this into a triangular shaped mesh here. Okay, when you convert this, you don't know the values of the resistances here in the delta. Okay, this and this is the same thing, it's just a different way of writing it. A, B, okay, take it that X, Y and Z. Okay, the ends, these ends are also X, Y, Z. So in a circuit, if you have star, you can just remove it, and I'm sorry, here this is Z. Okay, you can just remove it and put the delta in place. Okay, so let's name this as RA, RB and RC. Okay, RA, RB and RC, but you don't know these values. You know these values. Okay, you know the R1, R2 and R3, they are given. Okay, you don't know RA, RB and RC. So what you do is you have this formula, like RA is equal to, take all these resistances 2 by 2, R1 into R2 plus R2 into R3 plus R3 into R1. Okay, and now this is the same numerator for all three. For RB also you have R1 into R2 plus R2 into R3 plus R3 into R1. Okay, this is the numerator. Same for RC, R1 R2 plus R2 R3 plus R3 R1. Okay, this is the numerator. Now for the denominator, this is RA. So in the denominator, you take the resistance which is opposite to RA. These two are next to RA. Okay, this one is away from RA. Take the resistance which is away from RA, that is in this case R2, and write it in the denominator. Now same, take for RB, the resistance which is far away from RB is R3 here. R3 in the denominator and then for RC the resistance away from it is R1, so R1 in the denominator. It's just as simple as that. Now this is a delta network. You have to convert this into a star network. Suppose these elements are X, Y, and Z. Okay, you need to convert this into a star. That means you want to replace this delta and put in a star. Okay, so take this as R1, R2, and R3. Okay, here it's the opposite. You know the RA value, you know RB value, and you know the RC value, and you need R1, R2, and R3. So what you're going to do here is, so what you need to find here is R1, R2, and R3. So all three of these will have the same denominator. Okay, the denominator is going to be RA plus RB plus RC. Okay, you know RA, RB, and RC values. RA plus RB plus RC. Here also you have RA plus RB plus RC, and for R3 you have RA plus RB plus RC. The denominator is same in all the three cases. Now look at the numerator. You have R1. Okay, you want to find R1. Look at the resistances beside R1. They are RA and RB. These two are beside this. Okay, this one is far away. These two are beside this. So take this RA into RB. Okay, two resistances next to R1. Now R2. The two resistances next to this are RB and RC. So write RB into RC. Now go for R3. The two resistances next to this are RA and RC. So you write RA into RC in the numerator. That is delta star. Since we had requests, we decided to switch to mesh analysis, and I'm going to show you the easiest way to solve these things. Here you have I1, I2, and I3. Okay, first take I1. It shows, the arrow shows in a clockwise direction, and now the current flows in a clockwise direction. So we go in a clockwise direction, this direction. Okay, so start from here. This goes from minus to plus. That means from smaller to bigger there's addition. So plus 50. Okay, write it big here, plus 50. And then you go to this. The current through this resistor is I1. So, but across this resistor, always remember, across a resistor, the potential always drops. Okay, the potential always drops. So you always use minus. Okay, you always use minus. So minus 10 into I1. Now look at this. Through the 5 ohm resistor you have I1 flowing and I2 flowing. Okay, so now look at the direction of these two. Okay, look at the direction. This is clockwise, so when it comes here to the 5 ohm resistor, I1 flows in this direction. Okay, and then I2 flows in an anti-clockwise direction, and when you look at it at this place, it flows in this direction. So both currents are flowing downwards in the 5 ohm resistor. Both currents are flowing downwards. So you write here minus 5 into I1 plus I2. Both are flowing in the same direction. Both are flowing downwards through this resistor. So I1 plus I2. Okay, and now look at this, the last resistor. Here I1 flows in this direction. I1 is flowing downwards through this resistor. And look at I3. I3 is flowing clockwise, so look, I3 is flowing upwards. Just follow the arrow. Okay, I3 flows upwards. So both currents are flowing in opposite directions here. So you write minus 3 into I1, because it's flowing in the opposite direction, minus I3. Okay, I1 minus I3 is equal to 0. Okay, here you had I1 plus I2 because both are flowing downwards. Here, since they're flowing in opposite directions, you have I1 minus I3. Okay, so you simplify this equation, you will get 50 is equal to 50 minus 18 I1 minus 5 I2. Okay, this is separate. Okay, plus 3 I3 is equal to 0. Okay, then now you can write this as minus 18 I1 minus 5 I2 plus 3 I3. Take 50 to the other side, it becomes minus 50 is equal to minus 50. Okay, so you have this equation. I'm sorry it's not very clear. This is equation 1. Okay, this is equation 1. And now for equation 2, go to loop 2 here. Loop 2 is flowing in an anti-clockwise direction. Again, follow the arrow here. This is also a battery. The smaller line is the negative, the bigger line is the positive. Again, minus to plus, smaller to bigger, so addition. Okay, smaller becomes bigger, so addition. So 10 plus 10. Okay, plus 10, then always write minus before the resistor, always. Okay, minus 2 into the only current through this is I2. Okay, because it's not connected anywhere else. 2 I2 minus 5. Here again, I2 is also flowing downwards in this resistor. I1 is also flowing downwards. So 5 into I2 minus I1. Okay, first you write the current flowing in this loop, then second you write the current flowing in the other loop. Okay, now now that's it. You have two resistors is equal to 0. You simplify this, you get minus 2 I2 minus 7 I2. Okay, all right, minus 7 I2 minus 5 I1, and take 10 to the other side. Okay, take 10 to the other side is equal to minus 10. Okay, now this is equation 2. Now the third equation, in this loop, again, follow the arrow. Okay, just follow the arrow. So here's a resistor, so write minus as usual, minus 3, open your bracket. I3 and I1 are flowing in opposite directions. I3 is flowing upwards. Okay, upwards, it's flowing upwards to this resistor. I1 is flowing downwards to this resistor. They're going in opposite directions. So I3, first write I3 minus I1. Okay, that's it. And now you don't have any more resistors. Here you go, this is the bigger line. Okay, you're going from bigger to smaller. Bigger to smaller is minus. Okay, so write minus 5. Okay, minus 5, and this you can write it as plus 3 I1 minus 3 I3 is equal to 5. Take 5 to the other side, it becomes minus 5 becomes 5. Okay, now you have 3 equations here. I'm going to tell you how to solve them. Okay, 3 equations, and here we go. 3 equations are 10. Oh, I'm sorry. Okay, so I have here the 3 equations: equation 1, equation 2, equation 3. The same equations from the previous page. Okay, I wrote them. See, I wrote all I1s one below the other, all I2s here and all I3s here. Okay, just rearrange them so that all the I1s are in one column, all the I2s and all the I3s as well. Okay, now here you can open your calculator, normal Casio calculator, if you can see it there. Okay, just switch it on, go to mode, and then there you go to equation, that's 5, press 5. Okay, the second option here, okay, it has X, Y and Z. Okay, select that too. Now here, type in these equations. So here I have minus 18, go to the next one, minus 5, next one, plus 3 is equal to minus 50. Okay, minus 50. Next row, minus 5, minus 7, and we don't have any I3 term here. Okay, so write 0. Okay, where you don't have anything, you just write 0. 0 is equal to minus 10. Okay, minus 10. So you have it there, just write 0 here. Okay, and then you go to the third equation, you don't have any I1 here, so type in 0, go to the next one, plus 3, next one, minus 3, next one is equal to 5. Okay, everything is right, just check it out here. Okay, just check it out if everything is correct here, and then you can just press equal to. So you get x is equal to 2.54. so this x is your I1. Okay, first column was I1, so I1 is equal to 2.5, y is equal to minus 0.38. the minus does not mean your answer is wrong. The minus only means that in the diagram, in the circuit diagram here, as you had here, see, you had this direction for I2 according to the question, but the direction is opposite to that. Okay, that's all it means. It does not mean your answer is wrong here. So I2 is minus 0.38. Okay, and then I3 is minus 2.05. Okay, again, the fact that it is minus, it does not mean that your answer is wrong. Okay, it does not mean that your answer is wrong. It only means that the current direction shown in the diagram was not correct. Okay, the current direction shown here, it wasn't correct. The current direction shown here, it wasn't correct. Okay, so your answer is perfectly correct. This is the easiest way to do it. And now here's another problem. I'm sorry, I made a hash of the previous one. I'll try to do this one neatly. So here you have I1, I2 and I3. Okay, if you can see clearly here, and I'm sorry, this is 50 volts. Okay, I didn't write it here. This is 50 volts. This is a current source of 2 amperes. Okay, now this is very easy. Go to loop 1, just follow the arrow. Okay, follow the arrow, go in the direction of the arrow. So minus to plus, smaller to bigger. So plus 50 here, plus 50. Go follow the arrow. Here 10. Okay, you always write minus 10 into, what are the currents flowing through this? You have I1, which is flowing in this direction. Okay, so I1 is flowing downwards through this. I1 is flowing downwards to 10, and the other current is I2. I2 is flowing like this. I2 is flowing upwards. Okay, so they're flowing in 2 opposite directions here. Minus I2. Okay, I1 minus I2. Now come to this resistor. Here I1 is flowing in this direction, so downwards. I3 is flowing in this direction, so upwards. They're in opposite directions again, so you write minus. Always before resistor you write minus 5. They're flowing in opposite directions. Okay, remember. So I1 first, right? I1 minus I3. Okay, here you have to first write, here in this case you have to write I1 because I1 is the loop you're considering at the moment, and same here. Okay, first I1 and then I3 because you're considering this loop. Okay, this is equation 1. Now you come to equation 2, come to loop 2. Okay, so loop 2, you need not go for this. Okay, you can go for this whole thing as loop 2. Okay, you can go for this whole thing as loop 2. Why? Because I have a current source here. I don't want to mess with the current source. Okay, so that is why I take the whole loop. Okay, I'm sorry, this I didn't write equal to 0 here. Okay, this whole thing is equal to 0. Okay, now I take this whole loop. Again, I follow the arrow. Follow this, start here, minus 2, always minus 2 I2 because I2 is the only current flowing through it. Then again down here, minus 1 I3. That 1 I3 is I3 minus I3, and now this one minus 5 into I3. First you're considering this loop at the moment, so I3 minus I1. Okay, and then you added this resistor, right? Minus 10. You're considering this one, so you consider this current I2, and I1 is in the opposite direction. I2 is upwards. Follow the arrow. Okay, follow the arrow here. I2 upwards, I1 downwards, so opposite directions. I2 minus I1. Okay, that's it, equal to 0. Okay, if you simplify this equation, you get what? If you simplify this, you get minus 15 I1. Okay, minus 15 I1 plus 12 I2 plus 6 I3 is equal to 0. Okay, same thing, you simplify it, you open the brackets up and just write it down, you get this. Okay, now for your third equation. Okay, we just took this loop and this loop. Look at this, is a current source. Okay, this is a current source, so look at the currents flowing through this current source. Okay, 2 amperes current source. I2 is flowing in this direction and I3 is flowing in this direction. Okay, if you can look at it here, so I2 minus I3 is equal to 2. You may ask why not I3 minus I2? Because the direction of the current is the same as I2. Okay, so you take I2 first, then I2 minus I3 is equal to 2. Okay, not I3 minus I2. I2 minus I3 is equal to 2. Okay, so we have 3 equations here. Let's write them down. Okay, so here we've got these 3 equations. Okay, the same. I1, all I1s in the same column, all I2s in the same column, all I3s in the same column. Then it becomes easier. So you go to your calculator, again mode. In mode you select phi, that is equation, and in equation 2. Okay, so 15 here, 15. Then you have minus 10 I2 minus 10. Okay, then minus 5, then you've got 50 on the other side. Okay, 50 on the other side. Then here you've got minus 15, 12 and 6, 12, and then you have 6 I3. Okay, so 6, and here you have 0. Okay, on the other side 0. I'm sorry, in the third equation, this is 2, okay, not 0. Okay, so here you have 0, okay? 0. Don't leave it blank, okay? This looks like a 0, but this is a blank space and you will get a wrong answer if you do this. So the final answer, you don't have an I1, so write 0 instead, okay? Do not leave it blank. Do not leave it blank, write 0. Okay, I2. So 1 minus I3. So minus 1. And then you have 2. Yeah, okay? That's it. You solve it. X is equal to 20, which means I1 is equal to 20 amperes. Y is equal to 52 by 3, so I2 is equal to 17.33 amperes. I3 is equal to 15.33, okay? 15.33 amperes. There you go. These are your answers. So that is the end of this video. If you have any suggestions, please leave them in the comments below. And you can always mail us at trippleecoronia2016@gmail.com. We're looking forward to clearing your doubts, and we'll try to answer most of your questions. And have a good day.